Hello, my name is Brett Molyneux, and in this Chiptorial, I'll be going over a critical piece of the crypto authentication family that makes Microchip's secure ICs agnostic of any MCU. And that critical piece is the CryptoAuthLib Library. Microchip secure ICs can store cryptographic keys and certificates necessary for executing secure authentication operations with devices like microcontrollers and microprocessors. The controller initiates this process by sending a random number challenge to the secure IC, which subsequently generates a response and sends it back to the controller to be approved or denied. CryptoAuthLib is the library supporting communication between these devices, making communication scalable from one security use case to another. CryptoAuthLib plays a critical role in establishing the connection between your secure IC and a microcontroller or microprocessing unit. It is a C-code-based software library stored on GitHub. It forms an essential part of any application or device driver seeking cryptographic services from a crypto authentication device. It runs seamlessly on PCs with Windows operating systems or embedded Linux platforms. Its primary function is to supply users with a set of functions that systematically guide secure ICs in executing specific device operations, ultimately shaping a use case. So what exactly does the CryptoAuthLib library contain? CryptoAuthLib is comprised of three primary types of functions. The initial category, hardware abstraction layer APIs, is also known as HAL functions. These functions facilitate secure IC interactions with peripheral drivers, such as those found in MPLAB Harmony, that are essential for MCU hardware operation. HAL functions then feed into the second category, which are CryptoAuthLib core commands. These functions encompass all finite operations available within the CryptoAuthLib library. Users typically do not directly implement these into their projects to avoid complicating the project development process. The final and highest level of functions are known as CryptoAuthLib basic APIs. These are the functions that customers are expected to use within their projects. These APIs orchestrate the execution of specific CryptoAuthLib core commands in order to carry out each step within a use case. For instance, a basic API like atcab_random instructs the host MCU to generate a random number. For an authentication use case, this random number is sent to the device being authenticated as the initiating step in the process. An additional component to this level of functions is third-party TLS functions. These functions specifically support operations such as mbed TLS and wolf SSL that might be needed for specific use cases. Both third-party TLS functions and CryptoAuthLib basic APIs can be directly implemented into your project, or you can implement them through the Trust Platform Design Suite software or through the CryptoAuthLib library plugins for MCC or Harmony. Now let's explore integrating the CryptoAuthLib library into your project. So your first option for that is to download one of our CryptoAuthLib library plugins that we have available for either MCC or Harmony. Your second option is to download the Trust Platform Design Suite software, which is equipped with code examples for your use. Developers can incorporate CryptoAuthLib into their project by downloading the MCC or Harmony CryptoAuthLib library plugins. Once you have the plugin downloaded, CryptoAuthLib will be integrated into your environment like you can see here. When you set up the project in MCC or Harmony, you will be guided to choose your MCU device, which will automatically set up the correct peripheral drivers for your project. All that's left to do is select your crypto device in the device resources in the drivers section. Then you will connect your I2C options on the MCU and the crypto device in the project graph, like you can see here. Once you do this, you will be set up with the appropriate HAL functions for your project automatically. You can also see your crypto device in the project resources and your configuration in the Configuration options. To see the generated HAL functions, you can click on the Projects tab and go to Libraries, then CryptoAuthLib, then HAL, and for this example, you'll see the ATE-CC608 device under HAL functions. Another option for those seeking assistance in constructing their use case effectively, there are detailed code examples for each use case within the Trust Platform Design Suite software. To access these code examples, you can select a use case and a product, and a use case page will open like you can see here. This page gives a comprehensive view of the entire process for this use case. It also provides a transaction diagram with the CryptoAuthLib basic APIs executed for the use case that you can see here. Upon completing the transaction diagram, developers can simply click on the MPLAB X project button, and the embedded project for this use case will be pulled up with all the CryptoAuthLib APIs associated with the use case. Users can also use use case TPDS embedded projects as a reference for how to construct and implement the CryptoAuthLib APIs. Now let's explore the most important files on the GitHub page for the CryptoAuthLib library. On the GitHub page hosting CryptoAuthLib, developers should focus on these folders, the lib, test, and app folders. The most critical folder is the lib folder, which holds all the functions available within the CryptoAuthLib library. When we open the lib folder, we will encounter the CA lib subfolder, which contains the CryptoAuthLib basic APIs and the cal core commands. There is also the ATCA cert subfolder, which contains specific APIs for certificates. Then finally, there is the HAL subfolder, which contains all the hardware abstraction layer APIs. This folder is where you will need to place all your HAL files pertaining to your MCU peripheral driver. CryptoAuthLib has several examples of HAL implementations that you can reference when building your own. Moving back out to the main page on GitHub, in the app folder, there are functions that have been constructed on top of the CryptoAuthLib library with examples such as ATE-CC608 Trust and Go functions and other ready-to-implement functions and use cases. Finally, for those interested in exploring the testing methods for the library, they can be found in the test folder. In conclusion, CryptoAuthLib is a very powerful library that makes it possible for any microcontroller or Linux processor to interface with Microchip's secure crypto authentication or crypto automotive ICs. It also offers multiple methods for constructing your use case. To get a better understanding of how CryptoAuthLib APIs are used, you can access C Code turnkey projects by downloading the Trust Platform Design Suite software, which is loaded with examples for multiple use cases. You can go to the GitHub page to access the APIs directly, or you can download the Harmony or MCC plugin for easy integration into your project. Thank you for your interest in this Chiptorial. If you enjoyed it, please give us a thumbs up and subscribe to the Microchip YouTube channel. For more information on CryptoAuthLib, please look to the links in the description below. Thank you, and we'll hope to see you again for more Chiptorials.